analysis. Let's solve some radical equations, right? This is what we've been building up for. So we've been doing all this operational work with radical expressions, and we have yet to look at any equations. And so here we are. We're going to start finally looking at equations that have radical symbols in them. Specifically, there could be a radical in an equation, but it's not a radical equation unless it's the variable that's underneath the radical. So when I talk specifically about radical equations, I'm talking about when there is an x or whatever your variable is that's actually stuck under the radical, and what do we do about it? Okay, this is not considered a radical equation. This is an equation where I can solve for x, but it's not stuck under a radical. Okay, so this is the kind of equation I'm talking about. One of the things we're going to have to watch for when we solve radical equations is something called extraneous roots. So these would be answers that we get that make sense in the way that we're solving the equation, but when we go and check them and plug them back into the original, they don't actually work to give us a correct answer. So we're going to have to be on the lookout for that. And I actually used a question in my example that had an extraneous root to show you we're going to be on the lookout for this particular thing. Okay. So we're going to have to reject answers that result in a negative number coming out of a radical. All right, so that's what we're going to have to be kind of on the lookout for. So this is our example here where I've got to isolate the radical symbol first, then I can square both sides, and we'll do a few examples of this. It's really going to be mostly me doing examples today just to kind of help you and show you how to then check your answers, right? Then you get an answer for x, right? And then afterwards, we're going to check it by plugging it back into the original expression and equation. So we're going to check that by plugging it back in to see, does this work? Well, 7 plus 10 is not actually equal to 3. So I was technically not allowed to keep this answer. So I reject it, just like this. Okay. And so sometimes you might have no solutions as your answer because you had to reject everything you got for x. All right. We're going to look at that a little bit. So let's start with exercise 1A here. So your radical is already by itself. So since my radical is already by itself, I can immediately go to the step of squaring both sides because a square and a radical cancel each other out. So you're left with x minus 1, bring down your equal sign, and then on the other side, you square that. So 2 times 2 is 4. Now we need to get x all by itself, so we add 1 to both sides of the equal sign. We get x equals 5. Now I'm not going to box that in as my final answer yet. I'm going to check it real quick. Now checks can happen in your head. I don't necessarily need to see them written, but you do have to do them because if you don't reject an extraneous root, I'm going to know about it and I'm going to have to mark you wrong knowing that you didn't check. So I'm going to write out my check just so you can see what it looks like. But again, when it comes to the homework, you don't have to write them out. You can just do them in the graphing calculator. So I got 5 as an answer. So let's check 5 minus 1 under the radical should equal 2. Well, 5 minus 1 under the radical is 4 under the radical, and the square root of 4 is 2. So I get a correct answer. The reason that we're saying we can't get a negative number under the radical, so we haven't done imaginary numbers yet, and we can't get a radical to give us a negative answer is because notice this is a positive radical only. It doesn't have a plus and minus in front of it. So I'm only accepting whatever the square root of 4 is that's positive that comes out here. That's the reason that we have to watch for that. Okay, I do, thankfully, get to keep 5 as my answer for x here because it did check out. There we go, our first example of that. More often than not, because this is the point that we are at an Algebra 2 level, we're going to end up with questions like B, where, yeah, my radical is all by itself already, but when I square both sides, I am going to end up with an x squared. So, of course, getting quadratic equations is going to be very obvious and very common with all of this. Square and square root cancel each other out, so I just bring out the stuff in the radical. So that's always going to be nice. Really, those are just going to cancel. I don't have to worry about anything with that just yet. I do notice though, I have an x squared, so I'm going to have to bring everything over to be with the x squared. So add the 2x to both sides and add subtract the 3 from both sides. And remember, line them all up so they're in descending exponential order. Set equal to 0, of course. And now we factor. What are the factors of 3 that are going to subtract to give me a 2 in the middle? Well, the only factors of 3 are 3 and 1. So just make sure you have your signs correct. Positive 3 and a negative 1 inside the binomials. And now t-chart. Some people are doing some funky stuff with the t-chart, but what you need to make sure you do is set each factor equal to 0. I've got to see that. You can't just go directly to the answer. I've got to see that you've set each factor equal to 0. And we get x equals negative 3 and x equals positive 1. Now we have to check both of those answers. So before I can box anything in, right, I'm going to check. And I'm going to start with checking negative 3. So negative 3 equals radical 3 minus 2 times negative 3. Now, I'm going to tell you right now that I'm going to end up rejecting that answer. And the reason is, right now, I have a negative number outside of a radical. I don't care what this radical is, it's not going to, we're not going to take that square root and get a negative 3 out of here. So this is going to end up being rejected. So we're going to have to cross this out and reject negative 3 right off the bat. I can tell you that right now. Can't have a negative coming out of a radical that doesn't have a plus or minus in front of it. You can only have that positive coming out. So let's hope 1 works. And now I'm going to check that guy. Okay. So here, let's see. 2 times 1 is 2, 3 minus 1 is 1, and the square root of 1 is 1. So this does work out, and this I can keep as an answer. So I did have to reject the negative 3. I do get to keep the positive 1. I am going to tell you right now, you can't just automatically reject a negative. Okay. Notice I plugged this in and saw that there was an x on the other side of a radical already by itself, right? So I had a negative on the other side of a radical already by itself. That's how I knew I needed to stop and reject, because I wasn't going to have the radical bring out a negative number. Okay. So because of that, this particular negative did have to get rejected. Sometimes you reject positive numbers. Sometimes you don't have to reject anything. Sometimes you have to reject everything. So it's always a matter of checking to make sure this answer is going to be okay. So even better than all this fun stuff is if you have 2 numbers on the other side of your equal sign, an x and another number, and you've got your radical already all by itself, squaring both sides is going to look real different. Sure, here, the radical and the square cancel each other out, but right here, you now have a binomial squared, which is foiling, which means you have to rewrite this out as the binomial times itself, because 9 times out of 10, when you don't rewrite that, you don't remember to FOIL. So you want to really make sure you rewrite that as the binomial times itself so that you remember to make sure you FOIL this out. Oops. There we go. X times x is x squared. So you remember to make sure you FOIL this out, because otherwise you'd be missing out on the middle term. You might not get this correct. So now I'm going to, now that I've done my foiling, I'm going to resolve the middle here where the like terms add up to negative 6x. And now, since I have an x squared, I'm going to bring these 2 things over to the same side of the equal sign as the x squared. Negative 30 plus 9 is negative 21. And remember that other side is equal to 0, so make sure you're bringing down the equal sign, and then we're going to factor. So the factors of 21 that will subtract to give me a 4, so x minus 7 and x plus 3. And then we t-chart, so we have to set each factor equal to 0. And I get x equals 7. And I get x equals negative 3. Okay, so now I need to plug those back into the original question to see if I get to keep them both, or if I have to reject one, or if I have to reject both. I'll start with 7. And you know what I'll do? I'll have my t-chart help me out with my checks. So what I'll do is I'll do 7 over here, and I'll do negative 3 over here. So 7 minus 3 equals the square root of 30 minus 2 times 7. Well, over here, on the other side of a radical all by itself, I end up getting a positive number. So I have to check what's going on under the radical here. So 14, 30 minus 14 is 16. What's the square root of 16? It's 4. So I get to keep x equals 7. On the other side over here, let's see, we've got negative 3 minus 3 equals the square root of 30 minus 2 times negative 3. Okay, so here's the deal. Negative 3 minus 3 ends up being a radical equal to a negative number, and that's not going to happen. So we are going to have to reject, and you do have to cross off and write the word reject. We are going to reject negative 3 in this case. Okay, again, I can't just assume that because the answer is negative that I am rejecting it, and I can't just assume that because the answer is positive that I'm keeping it. Of course, that happens the majority of the time, but that's not always the case. You can't just assume that. Okay. All right, so that was A. I'm going to zoom out just a little so you can see the problem as a whole. Right? Make sure that if you've got two terms on the other side of your radical and you're squaring, that you rewrite it as a binomial times itself. And so you'll already be able to know. So I'm going to leave that work there so you can see it as I do B. First thing about B that we have to resolve is the fact that the radical is not alone. So I actually need to add 3 to both sides of the equal sign so that my radical is alone. So my radical has to be alone before I square it. So now that my radical is alone, I can square both sides. And yeah, I end up getting a binomial times itself again. So here's some cancellations, and you get x plus 59 coming out of the radical. But over here, you actually get x plus 3 times itself. So you're going to have to FOIL. And you end up with x squared plus 6x plus 9. So at this point, I'm combining those like middle terms in my head. X times 3 is 3x, and x times 3 is 3x. So 3x plus 3x is the 6x that I get in the middle. Bring down this on the other side that we haven't dealt with yet. But do note that you have an x squared over here, so you're going to have to subtract. Okay, from both sides to get the x squared, everything to be with the x squared. Keep that x squared positive. I get 5x in the middle, and negative 59 plus 9 is negative 50. So what are the factors of 50 that will subtract to give me a 5 in the middle? And that would be x plus 10 and x minus 5. 5 times 10 giving me the 50, and 10 minus 5 giving me the 5 right here. Then t-chart. Set each factor equal to 0. Minimum, I have to see that part. And then you can state what answers you get, which is x equals negative 10 and x equals 5. But here's the deal. You got to check to make sure you can actually keep those, right? You can't just assume. So again, you don't have to write out the checks. You can use your graphing calculator, but I'm showing you what you are doing for checks, which is plugging those answers back in. So I'm going to start here, negative 10. Oh, sorry. Trying to make things up for my equation. Negative 10 is what I plug in for x. My equation starts with negative 3 over here plus the square root of negative 10 plus 59 equals negative 10. Okay, so I'm going to have to check that because I don't have a radical alone equal to a negative number. So I am going to have to check and make sure that that actually works out. Okay, then inside 59 minus 10 is 49. And what's the square root of 49? It's 7. So I get negative 3 plus 7 equals negative 10. Well, that's not true. Negative 3 plus 7 is positive 4. So since positive 4 does not equal negative 10, since that does not work, then this check didn't work, and we have to cross off negative 10 and reject it. Now let's try 5. Negative 3 plus the square root of 5 plus 59, equals 5. So everywhere I saw an X, I replaced it with a 5 because that's the value I'm plugging in here. And let's see, this time 5 plus 59 is 64. And what's the square root of 64? It's 8. Negative 3 plus 8 is 5. So this one works. So I get to keep X equals 5. Do you have to write out the checks? No. Do you have to do them? Yes, because you never know what you're going to end up rejecting. Okay. A lot of times you do end up rejecting negative answers, but it's not always. So you have to check to make sure you know whether or not you're keeping your answers at this point. Okay. So remember, the opposite of a square root is to square. So we get that radical alone first, and then we square both sides. If you end up with a binomial squared, rewrite it as the binomial times itself, so you remember to FOIL. Because if you don't FOIL, you'll miss out on that middle term, and that will be something important for the solving. Okay, so really take your time and do each step here. Don't try to skip up to do something. Make sure you're checking your answers. And again, checking your answers can be as quick as coming over here to the graphing calculator. So what I'll do here is I'll just check negative 10 and positive 5 in the graphing calculator for our question B here, show you what to do. So negative 3 plus the square root of negative 10, oops, need to see my 0, plus 59, okay? And so I've plugged that in, I get 4. Okay, well, I know that it's supposed to equal negative 10, so I know I need to reject 4. So now I try again, right? Negative 3 plus the square root of 5 plus 59 is 5. And I knew that needed to be equal to 5 because that was the answer on the other side. So see, I know this is rejecting, this is keeping, just by plugging that into my graphing calculator. So I don't have to show it. I can do it here, but I want you to actually cross out an answer and write the word reject if you're not keeping it. So that way I know that you've done the check, and it's kind of your way of you knowing you've done the check as well. All right, guys. Good luck. There are 2 different homeworks on this. So there's kind of a light version, and then we get into some of these more, the lengthier questions, okay? Let me know if you need anything. I'm more than happy to go through these with you. I love doing these radical equations. So good luck, guys, and I'll see you soon. We're applying that factoring right away. Yay! And for the rest of the year. So good luck. Bye, guys.